Welcome to Academic Digest class. They said a block of wood weighing 18 kg weight is dragged by a horizontally is dragged by a boy horizontally through a rope. If the tension in the rope is 8 kg when the wood is lying on the ground, coefficient of friction is 0.28. Calculate the resultant force on the wood, acceleration of the wood, velocity of the wood at the end of 10 seconds, kinetic energy acquired by the wood after 10 seconds. So I've already done this work, but here I used G to be 10. So I want to do it again, this time using G to be 9.8. So let's first of all always draw free diagram. They said this is number 12 under chapter 9, exercise 12 under chapter 9. They said I'm not doing A and B, I've already done it. So they said the C is where I'm focused on. So they said 18 kg wood. 18 kg. If it comes down here, it does 18 times 9.8. 18 times 9.8. Hey, 18 times 9.8. 176.4 Newton. Is dragged by a boy. So the boy drags this wood horizontal through a rope. Now, as he's dragging it, if the tension on the rope is 8 kg weight, 8 kilogram weight, convert it. So 8 kg weight, that is 8 times 9.8 again. Another one, 8 times 9.8, 78.4 Newton. That is mg. Since they talked about weight, W equals to, and weight is the same thing as force. Okay. So if you get this, as I've gotten this now, let's go back. They say coefficient of friction mu is equals to 0.28. Now they said, please, whenever you notice that a body is horizontally, the force, you remember, force minus frictional force is equals to ma. So notice a block of wood weighing 18 kg. Yes, is dragged by a boy horizontally. So is dragged by a boy horizontally. That means that this force here is the pulling force. Yes, so pulling force here is, I've told you in my first class that whenever you hear forward force, don't go and calculate friction on the forward force. You calculate friction on a part where there is movement. It tends to stop movement. So this is the block that is moving. This is where you have your friction. So that means the force that will be going negative direction here is going to be mu mg minus the dragging force, pulling force, is equals to total force, which is ma. That means in this case, watch, resultant force on the wood. In this case, this is just F equals to. So I'm now going to be having 78.4 minus 0.28, and this is 176.4 Newton. Let me do this thing well. It's looking one kind. 78.4 minus 0.28, that is coefficient of friction, times 176.4 equals to F. F is ma, but since it's the force, resultant force, they're asking us, no need putting it as ma. So first of all, 0.28 times 176.4, 49.39 minus 78.4 equals to F. So F is equals to 78.4 minus 49.39 29.39. So 29.01, approximately 29 Newton. So that's the resultant force. So the resultant force here is 29 Newton. I've told you, anytime you are calculating friction horizontally, this is your formula. Depending on if it's at equilibrium, A here will be 0. That means this P will be equal to. Now, acceleration of the wood. I said acceleration of the wood. Let me still go back. Using this now, I do P I. This is I. P minus friction equals to acceleration ma. Now, acceleration of the wood now will simply be divide both sides by m, divide both sides by m. Remember that already P minus F, that is, yes, P minus F, that is this thing now. Everything gave me 29. So that means I'll have this cancel this. And notice, it's acceleration of the wood they are asking about. So if it's the acceleration of the wood, the mass of the wood is 18 kg. If you remember, weighing 18 kg. So that means that what I'm using to divide is simply A will be equals to 29 all over 18. 29 divided by 18. So I have 1.6 meter per second square. Assuming they said acceleration of the boy, I'll use mass of the boy. But they said mass of acceleration of the wood. So that is why I'm using the mass of the wood. 1.6 meter per second square. Now the next question says the velocity of the wood at the end of 10 seconds. Velocity of the wood at the end of 10 seconds. So what I just need to do is I. So at the end of 10 seconds, I still come and put my formula P minus F. That is pulling force here is what they give me. Then I remember that velocity is actually V over T. So, and here I have, remember it's velocity of the wood they're asking about. So I have the mass to be 18. The velocity, I don't know it, but they said something about 10 seconds. I put it equals to P minus F gave me 29. So if you do this very well, you see that this can cross over and times this so that you have 290 equals to 18V. You can divide both sides by 18, divide both sides by 18. Simple mathematics. So V now will be equals to 290 divided by 18. So I have V to be equals to 16.1 meter per second. Very simple. Okay. Then they said kinetic energy acquired by the wood after 10 seconds. So after 10 seconds, I remember velocity here is after 10 seconds as well. So kinetic energy Ke is simply given by half mv square. So it's the same thing as saying, since they said after 10 seconds, thank God, because velocity I have is also 10 seconds. So it will be half, and is the wood they are talking about. Because they are talking about the wood, I will use mass of the wood, which is 18. Then velocity here is after 10 seconds. And kinetic energy they're asking me is after 10 seconds. So I just use 16.1 square. So by the time you punch it, let me punch. If I do 16.1 times 16.1, I get 259.21. Now times 2 here 1, 2 here 9 times 9. So kinetic energy will be equals to 259.21 times 9. Kinetic energy is simply, so the kinetic energy is simply equals to 2,332.89 in joules. That's the correct answer. So the one you have in your textbook was rounded up. They just rounded it up. So this is the answer. This is how to go about it. So I want to solve another question. This one says, let me be sure I've solved all the question. This is number 10. This one says, if you, no, I'm not answering all this one. From the B part, they say a log of wood 4.7 kg. Always draw free body diagram. So number 10. Number 10. Log of wood 4.7 kg. Mass. Lying on a horizontal ground. Coefficient of friction is 0.87. G should be taken as 9.81. Now, this thing like this. There was no drag, they did not say it was dragged. And so, but I just need to know that the force here on this will simply be, that is the weight, that is 4.7 times the 9.81 they said I should use. It will be, my God, this pen, it will be 46.1 Newton. 6.1 Newton. Now remember that for horizontal friction, calculating anything horizontal friction, we normally give it by P minus, that is F forward force minus frictional force is equals to total force F net. And this one will always be in mg. This will always be in mu mg. And this will always be in ma. So if I know this, let's go through the question again. Log of wood, they said just to enable it to calculate the horizontal force that can be applied to the wood to just enable it to move. I've told you in our first class, just to enable it to move, at that point, this A is 0, which means everything here is 0. That means that you now have force is equals to, that is force minus frictional force is equals to 0, which means that force will be equals to this crossing over friction. So just to enable it to move, it has not moved, but for it to move, at that point of it to move, it is still at rest. So at that point, the force must be equals to friction to enable it to move. And for it to now move, the force has to be more than friction. So that is why to enable it to move, it's still saying that it has to be equal to the friction for it to move. Then to keep moving, it has to be more than friction. It has to be yes, it has to be more than the friction for it to keep moving. So I want you to understand it is different from when we say static friction, the amount of force applied when it's starting. That is, static friction is greater than kinetic friction. It's different. The idea is different. You think about it when you come to do a lot of things about it, it settles inside you. So now if I know this is now going to be the same thing as saying force will be equals to mu mg. So that force will simply be equals to, that's 0.87 then times mg is here 46.1, so times 46.1. So 0.87 times 46.1. So it's going to be, yes, it's going to be F equals to 40.1 Newton. So just to enable it to move, that is your answer. Now, to give it an acceleration of 8,000 kilometers per hour, to give it an acceleration of 8,000 kilometers per hour second. Hi God, these people safe. So we'll now come and start converting. First of all, let's convert. First of all, 8,000 kilometers per hour square times, we know that 1 kilometer is equals to 1000 meter, and times, we know that 1 hour square, 1 hour is equal to 2600 seconds. So 1 hour square should be equal to 3600 square. So we put it in a way that hour will cancel hour square, kilometer will cancel kilometer. So you are now left with, if I do 3600 times 3600, I have this to be the same thing as 1296, that is 12,960,000. So I have this, it's okay. This cancel, this cancel, 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 cancel. So I now have 800 divided by 1296, 1296. So that you get 0.62 meter per second square as your acceleration. So I've converted. Now we'll go back to the formula. F minus friction equals to ma, and the a here is 0. So calculate the horizontal force. So the area is 0.62. The mass is 4.7. Let me do this here. 4.7 times 0.62 equals to the friction minus the friction itself. When I did this thing, I got, yes, this is the friction. I got 40.1. Then the force, I'm looking for the horizontal force. So this will be the same thing as saying 4.7 first of all times 0.62 is giving me 2.914 equals to 40.1 minus. So the horizontal force will simply be the horizontal force, the force that you apply. This thing, remember that time we did not have any dragging force. So the force you apply in this case when the acceleration is 0.62 will be equals to, if this crossover, you have 2.914 plus that friction 40.1. This should be around 42 or 43. So let me do it. I have 2.914 plus 40.1. So I have the force to be equals to 43.01, which is 43 Newton. So there you have it. Now the last one. Don't understand how they are getting 69.1 here. What are you doing, my friend? Yeah, God. What did they do to get? This is 8,000 now, is it not? You convert. So I believe I converted well. And then Sabi. So you now have the last one to enable it to move. To enable it to move a distance of 8,000 kilometer. You still convert kilometer. That is a distance. So kilometer, 8,000 kilometer to meter is simply 8 million. So you have 8 million meter. Yes. So if you know that in the first hour, first hour simply means 3,600 seconds. So let's go. Please, if that is the case, I'll have a situation whereby I need to remember f minus f equals to m a. And if I remember, to get distance here, I can use this formula. S equals to ut plus half at square. So taking it that this is at rest 0 times, so I can have this to become the same thing as saying 8 million, trying to get 8 million equals to half a 3600 square. I could just use it in that kilometer, but I want to convert. So if I do this, I now have 8 million equals to, this can go here and times, this times 2. Then I have a, then 3600 is the same thing as 12,960,000 in seconds. So if you times this by 2, it's 133 times 2. 8 million times 2 is 16 million. I know though, but I just want to be sure, because this textbook is getting me upset. So divide by 12,960,000. This will get out. So A is equals to this gets out. So I now have 1600 divided by 12, that is 1296. So I have A to be equals to 1.23. 1.23, yes, meter per second square. So let's go and substitute it. So I now have F will be equals to, if this crossover using this formula, remember from F minus F equals ME. So this will be F equals to ME crossover plus F. So F will be equals to the horizontal force when that distance is given, because we've gotten it from the acceleration, will be, this will be MA. Okay, from the last one, what did we get MA to be? Okay, sorry. Yes, MA, mass and acceleration. Okay, sorry. The mass we are talking about here, remember, Shebi, for that wood, the mass is 4.7. So 4.7 then times 1.23, then plus friction in this question is 40.1. So 40.1. So let's do it. We do 4.7 times 1.23. We have 5.781. So plus 40.1. So F will be equals to, if I do 40.1 plus 5.78, it will be 45.88. F is approximately 46 Newton. I know I'm correct. So there you have it. So I wonder why this man is having 69 here. So this is the question. If there is a mistake, or if there was a mistake, I don't even want to check, but I'll check later. Thank you. Subscribe to my channel.